All right, so you know that graphically when you did it using second calc 0, this is the answer you are going for. This is the answer you are going for. Okay? Well, back in those days, there were no graphing calculators, but they did graph by hand. They did graph things by hand. So what Newton suggested is let's do this process here. Okay? Let's say that somehow I can estimate that this is the answer that I want to start out with. It's an estimation. Okay? And they were really good at estimating things. So what he proposed was that, okay, find that x point on the graph. So the graph I'm looking at is this guy here. Okay? Why am I doing this here? I can do it better. Okay, so that's so what he suggested is take that initial estimate that you had, find that x value on the graph, and draw a tangent line at that point. Draw a tangent line. So here's your tangent line. Okay, that's your tangent line. Then what he proposed was that, hey, this is a better answer. This is closer to where I want it to be than where I started. Okay? So he said, well, and he didn't have anywhere to go, right? He never had a mall to hang out with, didn't have an iPhone to worry about, okay? Didn't have no Starbucks,
Sure he had friends.
no Facebook.
No, he had no friends. He's a loser.
So he said, okay, I'm just going to sit here and do this over again. Okay? So, see, he didn't have to worry about this. He didn't have to contend with this nonsense. Okay? So he said, I'll do it over again. So what he did was he said, all right, I'm going to take the x value that I just got as an estimate, get the point on the graph, and then draw another tangent line to that graph. And he did this by hand. Okay? He did this by hand. And see how it's kind of getting closer and closer to the answer you want? Okay? So he did this really by hand. Well, actually, I'm not sure if he did it by hand. But what he did was he did this mathematical stuff. Ready? Okay, I just want to see your reaction to this.
Ooh, actually, easy like that. Got it. Don't worry. I just finished it in my mind.
Okay, so why don't you copy this down and then I'll go over it, okay? Copy it down and then I'll go over it. So first of all, the thing to realize is that this is an iterative method. An iterative method is one where you start out with something, then you repeat the process again. And then you get a new answer. And then you repeat the process with this new answer. Okay? And you go on until you get an answer that is to your desire, to your satisfaction in terms of the accuracy. Okay? Okay? You need the derivative of the function right there. That's f prime. What is f prime then? Remember, this is fx. 1 minus 1 plus, because cosine is minus sine. Sorry? 1 plus 2 sine 2x. Okay? So what I want you to do is I want you to put the original function in y1. And in y2, you can put either the derivative function, or if this derivative function turns out to be very nasty for you to find, you can do y and derive y1. Okay? If you do the second method, it's going to be a little slower, but that's okay. Right? So if fx turns out to be a difficult function, you don't know how to differentiate it, you can always use n derive. Always use n derive. All right? So let me go fire my calculator up. So let me show you what I have in y1. So I didn't use the n derivative. I actually used the derivative function itself in y2. Okay? I didn't use n derivative. Okay, what you're going to do is you're going to go vars, y-vars, function, y1, parenthesis 0.5. And you're going to store this in A. So essentially what I'm doing is I'm doing the evaluation of this guy here. I'm doing this evaluation here. Okay, goes into alpha A. Is everybody with me on that? Sorry? A is a variable that you're storing it in. Cindy, where you been, man? Been with me for 2 years, Cindy? Oh, you mean where on the calculator it is? You're storing Fn. So this is what we are storing. Okay, that's what we are storing. All right, you're going to put this in A. Well, make sure you're in radian mode. Am I in degree mode? No. Okay. Shh, shh, shh. What do you have in y1?
X minus cosine parentheses 2x. And then I get the derivative y1 x.
And when you do y1, 0.5, you get. What do you do with smokers, man? I need your dad to come out here and put out the fires. That's what I need. Can you ask him if he can come by here sometime? Get his fire truck. To go on the truck. Okay, so then what you're going to do is you're going to go vars, y-vars, function y2, and you're going to do 0.5 there. Okay, for y2, you're going to store that in B. Oops. Okay, store that in B. Everybody get 2.68 something? Okay, put that in B. Okay? Right? Now what you're going to do is you're going to do this evaluation. This evaluation. So for this particular line, it's going to turn out to be 0.5 minus A divided by B, and you're going to put all this stuff in C. Okay? So let me show you what I mean. You're going to go 0.5 minus vars, minus alpha A divided by alpha B. And then store that in C. Okay? All right? You guys got me so far? Y2 is, okay. Monica, you got to stay with me. It's written right here. You can see it right there. Oh, your style is different. Okay, I'll be with you in a couple of minutes. Okay, let me move on with this. Yeah, your calculator style is different. Okay, now what you're going to do is you're going to start out with this, whatever you stored in C. Okay, you're going to start out with that, and you're going to repeat the process. So you're going to do. I don't think Newton ever said that. I don't think he ever did. You're going to do y1c now, because that's your starting value now, is C. Okay? And you're going to put this now in A. So you'll replace A with it. And you're going to do y2 of C and put it in B. And then you're going to do this division, except now in this division, you're going to actually use C. And put that back in C. Okay? So do these iterations until you find that the fourth digit doesn't change. So maybe you might get something like, I'm not sure what you're going to get, but let's say it's something like this, okay? 7985, 0.5122, 6935, 0.5122, 5499. So you can see that between here and here, the fourth place hasn't changed. This hasn't changed. This hasn't changed. Okay, so if I want the answer to 4 places, stop because it's not changing. Okay, so your answer here really would have been 0.5123. Okay, because you want to round to the 4th place. Okay, so fill in the table and give me the answer. And you can always check the answer by doing what? By doing what? By doing the second count 0 on the original function. Okay, second count 0, this guy should be the same answer that you get eventually there. Okay? You guys get me on that? Okay, work on that, and then there's one more problem for you to do when we are done.
And this is, we want to wait till C before?
Yes, that's right. That's right.
The third one does it, right?
Sorry?
Third one.
It could be, I don't know.
Yeah.
Could be. Then check your answer with second count 0. Okay?
And then, is that our answer? Like, what is the
And that is your answer to that equation. That's the root of your, yeah. So I want you to do complete 4 iterations. So notice that it's telling you do 4 iterations, okay? I'm not telling you to do it until the 4th decimal changes. Do 4 iterations. So there should be 1, 2, 3, 4 rows.
So you just want us to do 4.
4 rows, yes. Yes. Store that. So you need to write this down because the next one, if it's 0.5149, something, 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 then you hit the end. No, that's not. This is. See how you sort it? Okay, so do and make the entire table now for this one here. Okay, make the entire table for this one, and there'll be 4 rows in there. Okay, 1, 2, 3, 4.